This is how generally how people arrange cards in their hands. Yes or no? So that when it's your turn, it's easy to search what all cards you have. Right? This lays down the foundation of one more very interesting sorting algorithm. Let's start talking about that. So most of the time, if you see people playing with cards, what they do is they take one hand, put a bunch of cards there, which is already in ascending order, let's say 2, 4, 5, 10. Then take one card from the deck and insert it at its right place. Like, for example, this person took 7 and it is trying to insert this card between 5 and 10. This card between 5 and 10. This is going to give us a new sorting algorithm altogether. This sorting algorithm is called as insertion sort. This sorting algorithm is called as insertion sort. Now, what is insertion sort? How exactly it works? Let's start talking about that. Okay. So let's say you have a bunch of elements, right? And let's say these bunch of elements are sorted. Okay. So you have left part as sorted. And then you have a sequence of unsorted elements. Okay. This is a sequence of unsorted elements. So let's say you have two partitions. One is a sorted region. One is an unsorted region. What you do is from the unsorted region, you pick the first element and you try to find the correct place to insert it. How do you find the correct place to insert it? So the first element that we pick from the unsorted region is 5. So you will check. Is 5 less than 9? Is 5 less than 9? Yes. So definitely 5 will be to the left of 9. Then you go here. Is 5 less than 7? Yes. Then definitely 5 will be to the left of 7. Is 5 less than 3? No. That means 5 should come between 3 and 7. Right? Right? Same thing here. Again, what we are going to do? Now, we are going to pick the first element of the unsorted region. Is -1 less than 9? Yes. That means it will be to the left of 9. Is -1 less than 7? Yes. That means it will be to the left of 7. Is -1 less than 5? Yes. Is -1 less than 3? Yes. Is -1 less than 1? Yes. That means -1 will come here. And so on. So what you do, you one by one in insertion sort. In insertion sort, you one by one pick an element from unsorted region and insert it to the sorted part. And insert it to the sorted part. Can I say that? Okay. Okay. Let's try to take an example. Okay, cool. Now, initially, what you can say is that in insertion sort, we can consider a single element as a sorted region. Can I say that? Even a single element can be considered as a sorted region because we do not have a condition like selection sort that our biggest element should be less than the smallest element of the unsorted region. We do not have a constraint like that. So we can consider that if, let's say, a single element would have been there. Let's say just this much array would have been there. This would have been a sorted array, right? So what we are going to consider is that the first element is the sorted element and this is the unsorted region. This is the unsorted region. This is the unsorted region. Now, what we are going to do is we are going to one by one pick elements from the unsorted region. Can I say the unsorted region starts from index 1? Yes or no? So I'll say for j equals to 1, sorry, not j equals to 1. For I equals to 1, I less than n, I plus plus, right? Can I say we have to start with 4, then we will do 3, then we will do 2, then we will do 1. So can I say we are starting from index 1, right? This is index 0, 1, 2, 3, 4. You can say 0th element is already sorted. So we have to start inserting the elements from index 1. So we will consider this as the unsorted part. So we have to start with 1. So I'm starting I with 1. Can I say that? Yes or no in the chat, guys? Is this point making sense? And now, what I'm going to do is, I have to take a look on the left side. Okay? So I'll say, for j is equals to I minus 1, j greater than or equal to 0, j minus minus, right? That means, let's say I is here and j is here. Because you have to go to the left side, right? You have to go to the left side. Yes or no? Right? So we have to do a reverse loop. So we start with I minus 1 because you start with the last element of the sorted region. That's I minus 1, right? And you go till the 0th index. And then, let's say, we will say element is equals to ARR at I. So in our case, currently, element is equals to 4. Okay. Now what do? We will check. If ARR at j is greater than element. Right. So what we do is, if the element at the jth index is greater than the element we want to insert. What is this element? This is the element we want to insert. Element we need to insert. Okay. We will check. Is 5 greater than 4? Yes, it is. Then definitely 4 is going to be to the left of 5. Right? So what we do is, instead of swapping, what we can do is, I can shift 5 to the right. Because I know that 4 is going to be on the left side of 5. So what if I shift 5 to the right? How do we do that? We say ARR at j plus 1 is equals to ARR at j. Right? Interesting, isn't it? So what is j plus 1? J plus 1 is this index. So what we do is, we put 5 here. And now, technically, we have shifted this 5 here, and this 5 is a dummy value. Okay? Cool. So we shifted 5, then we move ahead, we do j minus minus. Right? The moment you do j minus minus, j becomes minus 1. Is minus 1 greater than or equal to 0? No. That means this for loop ended. Can I say that? Okay. If this for loop ended, can I say, what is the right place to put 4 now? The element that we wanted to put was 4, right? It is at the index j plus 1. Can I say we have to put 4 here? We have to put 4 here, right? So we will say ARR of j plus 1 is equals to element. What is j plus 1? 0. What is element? 4. So you put 4 here. And can I say now this region is sorted? This region is sorted. This region is unsorted. Can I say that? Let's repeat this process one more time. You will get a better understanding. Okay. Cool. Now, I becomes 2. So I comes here. I comes here. So 3 is the element under consideration. So element is equals to 3. 3 is the element under consideration. So element is equals to 3. Okay. Cool. We start j with I minus 1. We start j with I minus 1. So j comes here. J comes here. Okay. Cool. We compare. Is the element at j greater than 3? Yes. That means 5 is greater than 3 means 3 is always going to be the left side of 5. So let's shift 5 to the right. This step is shifting j to right. Okay. So let's shift 5 to the right because we know that 3 is definitely going to be to the left side of 5. So let's prepare a vacant spot. So I'll put 5 here. I'll put 5 here. I'll put 5 here. Okay. And then j minus minus. We come here. Is 0 greater than or equal to 0? Yes. So we check again. We check again. Is this 4 greater than 3? Yes, it is. Yes, it is. Right? So what we are going to do is we are going to push 4 to the right because we know that 3 is always going to be the left of 4. So what is going to happen? What is going to happen? We will say ARR of j. That means ARR of 0 is going to be put at ARR of 0 plus 1. That is 1. So we will push 4 here. So this becomes 4. Can I say that? Shift. We are shifting. And now this is a vacant spot. So you can see we are moving the vacant spot. So that the moment we find the right spot, we put it there. Okay, cool. Also, let's make this element as 3. Okay, let's make this 3. Come back. Now, you shifted 4. Now you do j minus minus. J minus minus. J is again at minus 1. Is minus 1 greater than or equal to 0? Think about it. Is minus 1 greater than or equal to 0? No, it is not. So we will stop the loop here. And the moment we stop the loop, we'll do ARR of j plus 1 is equals to element. What is j plus 1? It is 0. So here you need to put 3. So we'll put 3 here. And can you see now the sorted region has expanded and unsorted region shrinked. Let's try it again. Let's do it again. Okay, let's do it again. Now the next iteration of I is going to be here. I will be here at index 3. Element will be ARR at I. That is 2. 2, right? Okay. Now, j start with I minus 1. J is here. Is 5 greater than 2? Yes, it is. We shift 5 to the right. This becomes 5. J minus minus. Is 4 greater than 2? Is 4 greater than 2? Yes. We shift 4 to the right and make a vacant spot. We put 4 here. And j minus minus. Always j plus 1 is the vacant spot, guys. J plus 1 is the vacant spot. Then, is 3 greater than 2? Is 3 greater than 2? Yes. We push 3 here and do j minus minus. Now j becomes minus 1. The loop ends. The loop ends. Right? And at j plus 1, we are going to put 2. That's it. Right? Now one last iteration. In the last iteration, I is again at 3. So element is 3. Now let's take a look again. J is at 5. Is 5 greater than 3? Yes, it is. So you shift 5 to the right. 5 comes here. And j minus minus. Is 4 greater than 3? Yes, it is. So you shift 4 to the right. 4 to the right. And you do j minus minus. Now this is the vacant spot. See, j plus 1 is the vacant spot. This is the vacant spot. Is 3 greater than 3? Is 3 greater than 3? No. You can see, is 3 greater than 3? No. So in fact, the moment you realize that you found an element x which is not greater than your element here, can I say behind this element also you will not find anything? Can I say that? The moment you realize 3 is not greater than 3, you can say 2 will also not be greater than 3. Anything to the left of 2 also will not be greater than 3. So what you can do, you can break here. You can break here, right? So the moment you realize, is 3 greater than 3? No. You break out of the loop. You break out of the loop. At ARR of j plus 1, you put element. So what is j plus 1? This was the vacant spot. You put 3 here. And can you see the whole array is sorted? That's how selection sort works. How it is different from bubble sort and insertion sort is that it is not doing swapping exactly. There is some level of swapping, but we are referring to that swapping as a push. That swapping as a push. That's the interesting part, guys. Let's try to quickly code it, guys. So if you want to code insertion sort, whatever I wrote, it's going to be used as it is. Public static void insertion sort. It will take an array. We'll say for int I is equals to 1, I less than length I plus plus. Okay. Why I is equals to 1? Because we assume 0th element is already sorted. Then we get the element ARR at I. And then we start j from to the left side of I, go till 0, and we compare. If ARR at j is greater than ARR at j plus 1, we push. We say ARR of j plus 1. Oh, sorry, not ARR at j greater than element. We say ARR at j plus 1 is equals to ARR at j. Right? Else, the moment we realize that ARR at j is less than or equal to element, we need to break. Right? We need to break. And at last, we say ARR of j plus 1 is equals to element. That's it. So I'll take the input from bubble sort. I'll copy paste this input here. Okay. Cool. and I'll call insertion sort. Now, if you carefully see, it is throwing us an error that j cannot be resolved to a variable. Why? Because we are using j in the loop and we have initialized j in the for loop only. And we want to access j outside. How do you do that? You need to do something like this. Int j here. Now what will happen? J will be accessible outside the for loop of j as well. Right? That's it. If you run it, you can see already sorted array stays sorted. If you take an unsorted array, this also gets sorted. How cool is that? That's how insertion sort actually works. Make sense, everyone? Don't worry, Rakesh, I'm there. But do you guys now understand how things are working? We have step by step diagrammed this whole algorithm, right? Do you guys now understand how things are working? Okay. Now, I want you guys to do an exercise in the class. Let's do an exercise in the class. We have been talking about time complexity and everything for a lot of time. Take 5 minutes. Take 5 minutes, okay? I will be shutting down the chat. So now you guys won't be able to chat. So you guys won't be able to share your answer so that it doesn't get spoiled for anybody else. Take 5 minutes. Think about what will be the worst case in terms of time and space for insertion sort. You guys have exactly 5 minutes. Okay. I'm starting a timer as well. Okay. The code is open in front of you. I'll be starting a timer and you guys will be having 5 minutes. You won't be able to chat with anybody else. I won't be doing anything. You have to think thoroughly. Maybe you think it in the first 10 seconds only, but I'm giving an average time of 5 minutes to everybody. Think about what is the worst case. Let me write it. Think about worst case time and space. Make sense? Start, everyone.